Hi friends, in this video I want to discuss the classification of systems. First we will see different types of systems and then we will go ahead with the classification of systems. Actually the systems based on the inputs, number of inputs and number of outputs, there are two classifications. One is system with single input and single output signals. So here this is a system and it has only one input x and one output y. So this is called single input single output system. And the other system is with multiple inputs and multiple outputs. So here the inputs are from x1 to xn and outputs are from y1 to ym. Yeah, next the classification. So there are 4 to 5 classifications are there in systems. So those are continuous time system and discrete time system, linear time system and nonlinear time system, time invariant and time variant systems, causal and non-causal systems, static and dynamic systems, stable and unstable systems. Okay, let us see one by one. First, continuous time and discrete time systems. Yes, if the input and output of the system are continuous time signals, then the system is called continuous time system. Okay, it's very simple. So here x of t is the input signal and that is continuous time signal, and y of t is also continuous time signal. If that is the case, then the system is called continuous time system. Similarly, if the input and output of the system are discrete time signals, then the system is called discrete time system. Like this. Here xn is the discrete time input and yn is the output, that is also in discrete time. So this system is called discrete time system. Linear and nonlinear systems. That means if, for example, if capital T is the operator, it satisfies the following two conditions, then capital T is called a linear operator and the system represented by a linear operator capital T is called a linear system, otherwise it is called a nonlinear system. Let us see what are those things. A system which satisfies the superposition principle is called linear system. That means superposition principle means we have to satisfy two conditions. First condition is additivity, second condition is homogeneity. Okay, let us discuss those things. First one is additivity. So what does it mean by additivity? Let t x1 is equal to y1. That means capital T is the system and x1 is the input. If we multiply these two, y1 output will come up. And same thing, capital T x2 is equal to y2. Okay, if this is the case, now according to additivity, capital T of x1 plus x2 is equal to y1 plus y2. Okay, this is additive property. So this property has to be satisfied for a linear system. And there is one more property called homogeneity, and this is called capital T alpha x is equal to alpha y. So this is also called as scaling. So whatever we are scaling the input, and that much scaling has to be done at the output. Okay, so these two properties has to be satisfied. So to combine these two properties, one more term is called, that is superposition term, superposition property. So superposition property means it is the collective nature of additivity and homogeneity. So the above equations can be combined into a single condition like this. Capital T of alpha 1 plus x1 is equal to, plus alpha 2 x2 is equal to alpha 1 y1 plus alpha 2 y2. That means here what we are doing, we are scaling the each input and we are getting the same scaled output and we are adding them. So for adding them is the additive property and scaling them is the homogeneity. So if we satisfy both the conditions, then the superposition property has been satisfied and we can say that that system is linear. If any system doesn't satisfy any of these conditions, then that is called nonlinear in nature. So the examples of linear systems are resistive system y of t equal to capital R x of t. Okay, same thing. We can, if for example, if x of t has some value alpha 1 x of t, then definitely it will be represented in the y. That means it should be alpha 1 y of t. Okay, same thing. Similarly, y of t equal to 1 by c integral minus infinity to t x t dt. Now x tau d tau. So this is for capacitor. So resistor and capacitor are linear systems. And coming to non-linear systems, x is equal to y is equal to x square. For example, if I increase the x to twice, so y will become 4 times of x square. Okay, so that's the case. So we can call that y is equal to x square is a non-linear system. Even y equal to cos x is another example of the non-linear system. So this is called linear and non-linear systems. Next, coming to time invariant and time varying systems. A system is called time invariant if a time shift, delay or advance in the input signal causes the same time shift in the output signal. Same time shift. For example, x of t plus 1. For example, y of t equal to capital T into x of t. For example, y of t plus 1 is equal to capital T into x of t plus 1. Then it is called time invariant system. Like this. Thus, what happened for a continuous time system, the system is time invariant if for any real value of tau, then this is the condition. Capital T x of t minus tau is equal to y t minus tau. Similarly, for a discrete time system, so above one is for continuous time system, below one is for discrete time system. The system is time invariant for any integer k, capital T of x of n minus k is equal to y of n minus k. A system which doesn't satisfy the above equations is called a time varying system. Okay, these are the conditions to make a system time invariant. For example, anything doesn't satisfy for continuous system, for continuous time system, above equation, for example, for any continuous system, it doesn't satisfy the above equation, then that is called time varying system. For any discrete time system, doesn't satisfy the below equation, is called time varying system. Okay, very simple. Next, causal and non-causal systems. A system is causal if its output y of t at any arbitrary time t equal to t naught depends on only the input x of t for t less than or equal to t0. That means the current, it depends upon the current value of the input, that is t equal to t naught, and the previous value of the input, that is t is less than t naught. Yeah, the output of the causal system at the present time depends on only the present n or past values of input, not on its future values. So this is t less than or equal to t naught, but it is not t greater than t naught. So it doesn't depend on future values. Thus, a causal system, it's not possible to obtain an output before an input is applied to the system. That means whenever you are applying any input to the system, then only, if that system is causal system, to get the output definitely you should have input to be applied. So without input you should not expect the output, because it never gives us the future values. Okay, that's a very important point. So a system is called non-causal if it is not causal, definitely. So that means it depends upon the future values also. So here x of t plus 1 is the future value. So it is called non-causal system. Next, static and dynamic systems. That means static system is a memoryless, whereas dynamic system is a memory system. Memoryless means it depends upon only the current value but not the previous value. Dynamic system means memory system means it has to store memory. That means it has to remember the previous things. That's all. Simple concept. Example, yt is equal to 2x of t. That means here t is there, here t is there. That means the current output depends upon the current input. Okay, so this is called memoryless system or static system. For the present value of t equal to 0, the system output is y0 is equal to 2 times of x0. Here the output is only dependent upon the present input, what we have discussed now. Hence the system is memoryless or static. So this is the example, y of t equal to 2x of t plus 3x of t minus 3. So the current value of y, okay, depends upon the previous value of the input. That means x t minus 3 is the previous value of the input. So to make that we need to save, we should have the memory. So for present value of t equal to 0, the system output is y of 0. Okay, that is equal to, it will give you x minus 3. So definitely we need to depend upon the previous value. So this system is past value for the present input, for which the system requires memory to get this output. That's why, hence the system is a dynamic system. Okay, it should be dynamic. That means it has to see the previous, it has to take the previous value also. Okay, so the next classification is stable and unstable systems. A system which has bounded input, bounded output is a stable. If for any bounded input x defined by modulus of x less than k1, that means bounded input means it is varying from one point to another point. That means, for example, x is varying from minus k1 to k1, for example. Then I should get the y in between any two values, bounded input and bounded output. That may not be the same. That means mod y should be less than some value. Okay, that is the concept. So the corresponding output y is also bounded, defined by mod y is less than k2, where k1 and k2 are finite real constants. Okay, then that system is called stable. For example, if the output of the system, the, for example, the output of the system from the bounded input, if it is not bounded, that means the value is not within the range, of defined range. The range may be defined, no problem. If that is not within the range, then that system is called unstable system. If for a bounded input it can generate the bounded output, then the system is called stable system. So the bounded means it should be in between two values for x and in between two values for y. The values may be changed. Okay, please keep that in your mind. So that's all. These are the different classifications of systems. So if you like this video, please like it. If you want to share this video, please share with your friends and family, and please subscribe to my YouTube channel and kindly press the bell button. And if you have any doubts, please write in the comment box so that we can discuss further. Thank you so much.